Alright, today we're going to go over Scatterplots and data analysis. Okay, I've got two definitions to start you out with and several definitions to go on after that, but we'll get into it. So bivariate data. Okay, this is just a fancy way of saying that the data has two variables. Okay, you see in our table here, we've got weeks, one value or one variable, and height is our second variable. So it's just a fancy way, bivariate, this is just a fancy way of saying it's got two different values. Okay, scatterplot is the relationship between the data on a coordinate plane. Okay, so we're going to end up graphing all of the data from our two variables onto this coordinate plane. Okay, so scatterplot is just, we're finding the relationship between all these values. Okay, all these variables are ordered pairs. Okay, is the data going up? Is the data going down? Does the data have no association at all with each other? Is it scattered out kind of all over the graph? Is it linear? Does it follow a specific line that we can see? Are there outliers? Are there variables or values that are way outside, far away from anything else? And is there clusters? So is everything bunched up in one spot or not? So we'll go over all those definitions after I kind of show how we're going to graph these like normal. Okay, so in this situation we've got X as our weeks, that's our X values, and Y is our height, our Y values there. Okay, I'm just going to write that down to remind me. Weeks and height. Okay, so our first value in X is 1. So we're going to go start from the origin, go over 1. Okay, remember X is here. X, Y. Go over 1, and then our Y value for that same week is 2. Okay, so at week 1 it was 2, let's say inches. Height in inches. 2 inches high. Okay, that's our first point. Our second point, 2, 4. So at week 2 it was 4 inches tall. At week 2 it was 4 inches tall. Okay, I think you get the point here. I'll go ahead and graph these pretty quick. 3, 5, 4, 7, 5 and 10, 6 and 15. Okay, so that's all of our data graphed on our coordinate plane. Okay, now we're going to go over some definitions that we can see if we have any here. Okay, so our first definition is positive association. Okay, positive association basically means is the data showing an increase. Is it going up? Okay, as X increases, Y increases. So as X gets bigger, Y also gets bigger. Okay. Negative association, just kind of the opposite. So as X increases, so as X value goes up to the right, does our Y value decrease, get lower? So a negative association would be pointing downwards, pointing down. Okay, no association means no obvious pattern. So if these dots were all over the place and it didn't look like it was going up or down, okay, that would be no association in the data. Okay, kind of scattered all over the place. Linear association, does it follow a straight line trend? So it doesn't have to be perfect on the coordinate plane, but if it follows kind of a spot, let's just kind of put one on this graph. If it follows one kind of line, we're going to call that linear. Alright, so if it follows a line, it'll be linear. It follows a straight line trend. Non-linear, obviously, if the data is kind of all over the place and it doesn't follow a specific line, like this graph up here does, you see how they're kind of all close to the same line, that'd be linear. If it was kind of scattered all over the place, we couldn't really make a straight line out of that, that would be non-linear. Alright, an outlier. So I didn't have a data point that showed an outlier, but just show a quick example. Okay, so if I had a point way down here, okay, I know that's not on the table, but if I had a point way down here, away from everything else, okay, that would be a good example of an outlier. You see how it's very separate and off that linear track, that positive association. It's kind of way out here all by itself, that's an outlier. Okay, last one is cluster, a collection of points that are close together. So in this example, we don't really have a cluster; they're kind of all evenly spaced. So if I had a lot of points all kind of close together in the same area, okay, and then a few down here, okay, that would be my cluster. That big group all together would be my cluster. Okay. And that's all our definitions there. So I'm going to do one of the examples from the problems I'm going to assign you. It'll be extra practice number 2. Okay. So the table shows the number of gold medals won by the United States Olympic team at the Summer Olympics from 1968 through 2008. Okay. So first we're going to do, just like my example, I'm going to graph that data that's from our table. So our year and the number of medals. Okay, they've already assigned the years are X values, medals is our Y values. We've got them all graphed here from the year 1968 to 2008. Okay, we've made that scatter plot. We're done with A. Describe the association, if any. Okay, so does it have a positive association, a negative association, or no association? Okay, a linear association or nonlinear. Okay, so it doesn't really rise or fall like a positive or negative. Okay, there's definitely an association. It's definitely linear. Okay, we see how it is a straight line here with one what? Okay, we would call that our outlier. All right, so let's say linear association. Okay, no real clusters. We don't see really collection of points. They're all kind of in line, but there is one outlier. So linear association, not positive, not negative. Okay, it is in a straight line, so linear. Okay, and there is one outlier. All right, and let's look at C. Is it possible to predict the number of gold medals won in 2016? Okay, apart from our one outlier, all these numbers are around the same number. Okay, they all kind of gather around this Y value of 40. Okay, so we can assume, because of this linear association, all around the same number 40, we can assume that in 2016 we're going to get pretty close to that same number. So we can assume 40, about 40. Okay, that's just because we've got everything kind of in the same area for many years in a row except for 1984. Okay, that's the only reason we can predict that far ahead. Okay, so if you have any questions, let me know.